Hello, and welcome to another segment of Show Me How It Works, presented by Nitek Security Transmission Solutions. My name is Chad Sakaris. I'm the National Sales Manager for Nitek. Today I'm going to be demonstrating EtherStretch, our unique network transmission solution. EtherStretch is a transmitter and receiver set which enables IP cameras and other networking devices to operate over extended distances of existing coax or UTP cables. In this demonstration, we've set up a traditional analog CCTV installation using coaxial cable. Beginning at the camera end, we have a power source, traditionally 24 volt AC or 12 volt DC. Power to the camera can be delivered from a centrally located power supply, or as we've shown here, from an isolated transformer located at or near the camera location. Once power is supplied to the camera, in order to transmit video signals to the DVR for recording purposes, we must connect the coaxial BNC connector to the BNC video output of the camera. In most traditional analog CCTV installations, the coaxial cable is routed in a home run fashion from the camera location all the way back to the DVR, which will be located in the security room or at the head end. Industry standards indicate RG59 coaxial cable has an optimum operating distance of approximately 750 to 1,000 feet. Field studies show the average length of installed home run coaxial cable being used in CCTV today is approximately 575 feet per camera. For our demonstration today, we're using 1,000 feet of RG59U coaxial cable. The BNC connector of the coaxial cable terminates to the head-end equipment, either the DVR, the multiplexers, the matrices, the monitor, or encoders. For our demonstration, we've connected a coaxial cable to the BNC input of a standard DVR for recording purposes. In the security industry, for many years we've installed CCTV equipment in this fashion. We're rapidly adopting IP cameras into security installations, and these methods pose cabling and infrastructure challenges. When installing network devices such as IP cameras, we must adhere to network cabling standards and practices. The cabling standard states that a maximum cable distance from a node to a network device is 100 meters or 328 feet. A node would be an IP camera. Network device would either be a network switch or a network hub or an NVR. In addition to cabling limitations, network devices operate over UTP cable, a Cat5 or Cat6. With the introduction of EtherStretch by Nitek, we help to overcome these challenges. EtherStretch consists of a transmitter and a receiver set, which allows for the transmission of IP cameras and other networking devices to operate over pre-installed or existing coaxial cable well beyond network limitations. Let's take a moment to discuss PoE. PoE, or Power over Ethernet, describes a system that's capable of safely passing electrical power over Ethernet cabling. There are two standards for sending power over Ethernet that are being used today. The standards are 802.3AF and 802.3AT. Both the standards are based on 48 volt DC power. Unlike analog CCTV cameras, which operate on 24 volts AC or 12 volts DC, which we've discussed previously. The reason that this is important to know is because most IP cameras operate on PoE standard. When developing EtherStretch, we created the ability not only to power our products from a PoE source, but also transmit the PoE over the coaxial cable to power the network device from the head end. A single power source is needed for all the items. To demonstrate the EtherStretch solution, I must first supply the receiving device with power. In this example, I'm using an inline PoE inserter to send power to my device. Many of your network switch manufacturers make their product PoE capable. Therefore, an inline PoE inserter would not be necessary. Once the network cable is connected between the PoE inserter and the network port of the EtherStretch receiver, you notice that the green power LED on the RJ45 jack became illuminated. When I connect the network switch to the PoE inserter, the amber link status LED will illuminate on the RJ45, indicating a connection to a compatible 10100 device has been made. This light would have illuminated simultaneously with the green light if I had connected it directly to a PoE switch instead of a PoE inserter. Once I supply power to my receiver, I'm then going to remove the BNC connector from the DVR and connect it to the BNC connector of the ether stretch receiver. Moving to the camera end, I remove the BNC from the analog camera and attach the BNC connector to the BNC input of the ether stretch transmitter. Once the coaxial cable is connected between the transmitter and the receiver, the power light on the RJ45 will illuminate to show that the transmitter is now active. The 10100 light will either illuminate fully or begin blinking. Illuminating fully will indicate 100 megabits of service. If the LED is flashy, it will indicate 10 megabits of service. The light is fully illuminated here, indicating that a link of 100 megabits of service has been achieved. Moving back to the receiving end, we can now see that the PoE out light is now illuminated on the receiver. This is an important feature as the 802.3 AF and 802.3 AT standard both state that PoE cannot be set unless they are connected to a PoE requiring device. During hookup, you may remember that the PoE out LED did not illuminate. The unit began sending PoE only after it checked the line and confirmed that the connected devices required PoE. A non-compliant device would simply begin sending voltage which could harm or damage network devices such as laptops, telephones, or other devices that do not require PoE. The final connection to be made is between the ether stretch transmitter and the new IP camera. Connecting a computer patch cord between the camera and the ether stretch transmitter will complete this installation. After the final connection is made, just as with the receiving end, the PoE out light on the transmitter will illuminate as the connected device has been checked and it has been confirmed that the camera connected is a true PoE device. The amber LED will also illuminate, indicating that a compatible 10100 network device is currently attached. It's that simple. In just minutes, we're able to install an IP camera or any other IP device to transmit over existing coaxial cable at distances far greater than network standards typically allow. This significantly reduces labor and material costs associated with technology upgrades. It also eliminates the need for cable abatement and additional network resources. The ether stretch devices are available in both coaxial and UTP configurations. We hope this installment of Nitek's Show Me How It Works was both entertaining and informative, and we invite you to view our website for many other innovative, industry-leading Nitek products. For Nitek, I'm Chad Sakaris. Thanks again.